Okay, now for question 13, we are asked to solve all the clicker questions for chapter 1, 2, and 3. So let's start with the clicker questions from chapter 1. So the first question in the clicker questions for chapter 1 asks us to find the sum of vector 1 and vector 2 and what it would look like. So in order to find the sum, you need to take vector 1. So here we have vector 1, and you need to place vector 2. You need to place the tail of vector 2 on the head of vector 1. So here would be vector 2. And then the sum would be going from the tail of the first to the head of the last. So from 1 to 2. This would be, let's call it 3. The sum of 1 and 2. So it would look something like this. That would be the sum. Now for the clicker questions on chapter 2, we're given this graph of cars driving down a straight road. And we're asked to see which one of the cars is reversing in direction or going backwards. So as we can see from the graph, none are reversing. Then we're asked to see which one of the cars is slowing down. And as we can see looking at the graph, all of the cars are moving constantly, so none are slowing down. Then we're asked to see which one of the cars is seemingly speeding up. And looking at the graph, we can see vector A is increasing in speed. So we can say that A is speeding up. Next, we're looking at which car is not moving. And if we look at the graph, there's only one car or vehicle that remains constant the whole time, and that is vector B or car B. So we can say that B is not moving, given that it's staying constant the whole time. And finally, for this question, we're looking at which car is moving in the negative x direction. And as we can see here, D is moving in the negative x direction. So we can say that it's D because he is decreasing. So he's going to the negative direction. Then another question in the clicker questions for chapter 2 asks us if x dry is 3, what would x wet be? And this is basically asking if braking on dry pavement gives you 3 times as much acceleration as when you're braking on wet pavement, then what would the acceleration on wet pavement be with respect to the dry? So basically it would be x dry is equal to 1/3 of x wet. This is with respect to x dry. So 1/3 x wet. Another question is asking us if you throw a ball off of a roof to determine the time the ball lands. And the only way you can determine when the ball will land is by looking at the height of the roof that it was thrown from. So by looking at the height, you will be able to determine the time t when the ball will land.